and statement. Do you guys remember what word they used for that? Oh boy. Conjunctions. Yeah, the word they used, they called it conjunctions, and the symbol was that. So it looks like an and, the symbol does. And today, we're talking about disjunctions. Guess what the symbol is?
Upside down.
A V. And it means or. Okay, what does or mean? So, or means if I say I'm either gonna go to, I don't know, Washington D.C. or California. Now, does that mean both of those have to be true? No. And means they both have to be true, guys. And means they both have to be true, but or means just one of them can be true. Now, in logic, or if they're both true, that's still okay. So if I end up going to DC and to California, that's still a true statement. So with or, at least one of them has to be true, or both of them. All right. So remember yesterday we had kind of the three cases. I don't know if I want to go over those real quick again because it takes a while. And I think we might have time. I'll do it super fast. X is less than 1, and say X is less than 3. So in that case, less than 1 looks like that, less than 3 looks like that. So if I combine them with an and, what do I use? It's where they both are right here. So it'd be X less than 1. Okay, what if it's X is greater than 1 and X is less than 3? Well, if it's between the two numbers, greater than 1, less than 3, yeah, use the stuff in between. Okay, and then the last one was the weird one. If X is less than 1 and X is greater than 3. What numbers are less than 1 and greater than 3? None. So the floating lines look like that. They have nothing in common, so the graph, we just leave blanks, no solution. Okay, now ORs will all have different answers on each of those. Let's just scooch over here. If I say X is, let's start with this one. X is less than 1 or X is greater than 3.
3.
Well, what numbers would that include? Would 0 be less than 1 or greater than 3?
No.
Listen again. Would 0 be less than 1 or greater than 3?
Yes.
Yes. Okay, or changes the meaning. Or changes the meaning. Is 0 less than 1
Yes.
or greater than 3?
No.
Okay, the or means one of them is true though, right? So, yes, 0 is less than 1 or greater than 3. Is 4 less than 1 or greater than 3?
Yes.
Yes. If it meets one of them, it works. Okay, so the only thing that doesn't work is is 2 less than 1 or greater than 3? No. So the floating lines look like this, which on yesterday's assignment, that was our no solution. Kind of scooched it over, but this no. But on the or, because it can be either of these or that, it doesn't have to be together. It's just going to be both of them. So the or is not picky. So they don't have to overlap. So it's all good. Okay, how about this one? Go in the same direction. Greater than 1, greater than 3. Now yesterday it would have been just these. All the numbers greater than 3. But if I make it an or, is 2 greater than 1 or greater than 3?
Yes.
Yes, because it's greater than 1. So if the number is covered by either of these, it's going to be part of the solution. Okay. by the way, is 3, the number 3 covered by either of these? Yes. So should I put an open circle here? No. Because 3 is part of the solution. Is 1 part of the solution? Is 1 greater than 1? No. Or greater than 3? No. So this is still an open circle, but this one is, 3 is covered. It's inside this one. So 3 is part of the, so I don't need an open circle right there. Okay, and then the weird one, so OR has a weird one also. There's the symbol. So 1, 2, 3. X is greater than 1 looks like that. X is less than 3 looks like that. Okay, what numbers are greater than 1 or less than 3?
All numbers.
Yeah, every number you could possibly think of would be covered in one of those. If you look at the graph, what numbers do this one or this one cover? Well, everything. Every number is covered. Do I need open circles right here? No. 3 is a part of this one. 3 is greater than 1.
When you graph it, would you graph it with an open or closed circle?
Neither. So here 1 is a part of this solution because 1 is less than 3. So every possible number is covered, right? Like I could have drawn these, could have drawn it like this, like every number is covered. So we don't need any circles down here because every number is covered. It would just be a continuous line. Okay. Do you guys know how to say, like, if we weren't graphing, how to say every number possible?
And then R.
Okay, yeah, it's all real numbers. Yeah, we've done this, right? It's all real numbers. You can write the words all real numbers, or you can use the fancy R for all real numbers. Okay, that's it. Those are the 3 types of problems. So it's going opposite directions and they just stay like that. It's overlapping in one direction and you basically use the farther back one. Just use whatever's covered by either of them is part of the answer. And then overlapping in opposite directions, that covers everything. So that one is just all real numbers. Okay. So people get today's and yesterday's confused. That's what makes it kind of hard. Number 1, in a conjunction, inequality statements are joined by the word and. That was from yesterday. Conjunction goes with and. So number 2, in a disjunction, the word is or. Number 3, we didn't actually talk about 3 and 4, so I'll just tell you what it is. It's not going to be on the test or anything, so I'm not really concerned about it. The solution to a disjunction is called the union. That's number 3. And the number 4, the solution to a conjunction is called the intersection. Union and intersection for 3 and 4. Here, I'll write it down. The answer on the disjunction on the ors is called a union, and the answer on the and statement is called the intersection. Okay, number 5, the symbol V indicates a what? Disjunction. That one, that's for today. It's not really a V, it just looks kind of like one. Number 7, we're graphing. Okay.
What?
Number 5, the symbol represents what? Disjunction, that's what we said. Okay. So number 5 or 7 has 2 and 5. 2, 3, 4, Okay, some of you did well at this, some not so well. I want us to, above the graph, this is not part of the answer, I'm gonna draw arrows. I did that every time yesterday. Some of us still didn't get it. X is less than 2, looks like that. It's not equals 2, so the circle is open. X is greater than 5, looks like that. Okay, if this is an or statement, which they all are today, I think. Did they throw an and in there anywhere? No, I don't think so. Okay, if it's an or statement, what are we going to use? No, that was yesterday. If it's this or this, it's okay that they're separate. Whatever is covered by either of them is part of the solution. So it's basically just going to be the same thing. So it's all the numbers less than 2 or greater than 5. It can be less than 2 or greater than 5. It's okay that there's nothing in common there. Number 9. X is greater than 2 or greater than 5. Okay, so this time they're both greater than, so they're both going to the right. What numbers are greater than 2 or greater than 5? Okay, everything after 2. So yesterday we only used this part, right? Because and means it's got to be both. But or means it could be either. So we're actually going to start way back here because either of them cover all these numbers. So starting back at 2. Number 11, less than or greater than -4. That's kind of a weird one. Alright, okay, they're only around -4, so less than -4 looks like that. Greater than -4 looks like that. What numbers would be included on this?
Both ways from
Okay, maybe it'd be easier to say this. What number is not included on this? -4. So the answer is basically everything but -4, like x doesn't equal -4. But the graph, which is actually the answer, is -4 is not included in either, but everything else is. So the arrows just means it keeps going forever. That's why we draw the arrows. Okay, 13 through 9 through 20, kind of like yesterday, we're just going to solve these. On the odds, I'm going to simplify them with you, and then on the evens, I'm not going to make you do that. There's nothing really to solve on 13, but we are going to simplify it. Not equals 6 or not equals 3. Yeah, this is probably... What numbers would not equal 6 or not equal 3?
6 and 3.
Not quite, no. No, we're not supposed to graph these. I'm just doing it to help us. The numbers that are not equal to 3 are all these. So everything but 3. Numbers are not equal to 6 are all these. Everything but 6. So, can you give me a number that doesn't fit that qualification? If I say 3, is 3 not equal to 6 or 3 not equal to 3?
It's not equal to 6.
It's not equal to 6, so it's okay. Is 6 not equal to 6 or not equal to 3? Yes, because it's not equal to 3. So every number is covered by one of these. Like, if you look at my graph, which you don't have to graph, but every number is covered by one of these. So it's all real numbers. And, yeah, you don't have to graph it, so we'll just write that. Number 14, you actually have to just solve those two, just like yesterday. I'm not going to make you simplify it. All right, number 15. Where did we leave off yesterday? I really don't remember. I feel like we went here. Miranda, you look guilty. You look guilty. How far did we get? Do you guys remember? I'm gonna guess. Oh no, did we get to the back table? I don't remember. We'll go Owen and then we'll jump to the back table. 15. That's kind of easy. Takes me a long time to write it down. Do show your work, as always. All right, Owen, what do we need to do?
Okay, we can add 6 on both sides on the left side,
Yeah, the left inequality, we can just plus 6.
and then the left side will be simplified, and then on the right side we can add 5 on both sides. And then we can divide by 3.
Okay, this one is a rare one where it doesn't. What numbers are less than 0 or greater than 15? Well, it'd just be all those numbers that are less than 0 or greater than 15. So this, unlike yesterday, this one doesn't really simplify at all. It just stays. It's like number 7 on the graphs. Oh, I forgot to divide, didn't I? But same deal. It doesn't simplify. Number 17. Oops. Wrong problem. All right. Okay, Miranda, what can we do on the left one over here?
Add 6.
And then,
Divide by 2.
okay, so we got b is greater than or equal to 10. How about on the right one? What can I do with those two guys? Well, you wouldn't minus 2b. That's to get rid of it on one side and like put it on the other side. If they're just on the same side, you can just put them together. So it's just ab plus 2b is 2b. Just simplify a little bit. Okay, now it looks like the other one. So what do I do now? Yeah. Okay. Remember to divide this time. This answer does simplify. What numbers are greater than or equal to 10 or greater than 3? Well, like 11 and 12, that would definitely work. So how about like 4 and 5? Would they be greater than or equal to 10 or greater than 3? Yeah, because they work for that one. So the simplified answer is all the numbers greater than 3. We are almost done already. I didn't give you guys enough homework. 3x plus 6, Leslie, you feel I did?
Yeah.
Thank you for sharing your. Guess we're not going to the back table then. All right, Moses, what do we do here?
You subtract 6 from -9, which is -15. And then we divide that by 3. And then x is less than or equal to -5.
Okay. I don't know why they made this one easier.
So the answer would just be x is less than or equal to -5, right?
Yeah. Well, no, I was wrong. The numbers less than -5 would be like -6, which does work. But would like 5 and 4 work? Well, yeah, all the numbers less than 6 work as well. It's kind of like one of these, less than -5, less than -6. So we're gonna, or +6. We're gonna use all these numbers. So if that includes everything less than 6. That's the simplified answer. Let me see that some of these look like a good bonus problem. Let me look at it for a second. 28 is large. Number 30? Is that what you said?
I said 23.
Oh, 22. I'm not gonna give an odd for a bonus. Answers are in the back. Huh? 28? Alright, we'll say 28 for bonus.
Means I only get 2.
Okay, 28 for a bonus, but I am gonna be, since it is a bonus, I'm gonna say you have to simplify it as well.
So we don't have to simplify it on all the other ones?
On the other evens. So remember yesterday I said you can just stop right here, you don't have to do that.
Okay.
But on the bonus, you do have to do that. I'll say 28 bonus.